Howdy there, welcome to day 11 of Weekend's Web App, the stream where we're building a complete web app from start to finish, although as usual, finish is a relative term. It might be like the Sydney Harbour Bridge where we just keep on going round and round and round, but we'll try and avoid that. Today we are working on IndexedDB. If you checked out yesterday's stream, you would have seen us get started, get a basic database in place. And what we're going to try and achieve today is actually get some data into that. And since there's a lot to do with that, we're just going to dive right in. So let me just move this along. And let's start. So we've got a little bit less organized than usual. It's in the middle of something leading up to this stream. Anyway, so if you want to keep up with what we're doing today, you'll want to be on day 10. That is yesterday's stream. So if you check out day 10 with the repository, you'll end up right where you need to be to follow along with the code today. Now, if we take a look at where we were at to begin with, so we had ourselves a basic schema here. We have categories, we have pages, we have authors and articles. So we have this this concept of migrations, and this isn't really our schema, but rather the actions that are necessary in order for the database to do whatever it needs to do in order to get everything ready. So this doesn't handle the actual aspect of what happens once you get it into the what happens to get data in, what happens to get data out, that kind of thing. So we're going to start to lay down some code that will let us put data into this system. And before we do that, however, we do need to make sure that this concept, this database storage concept, is sort of, how will we say? We need to make sure that this DB object, whatever it is, gives us some way to then work with the database that is sort of safe and won't start to do any actions until the entire database is ready. Because what I'm thinking is we will make a collection of files that sort of set up our data format. And in fact, we may as well do that right now. So we will make ourselves a directory. So it'll be in client, and it'll be test data. And inside that, we're going to make ourselves a file. So if we go client, test data, and we'll just go authors.ts. So we've got an interface for the concept of an author. Oh, that was shocking, isn't it? All right. So we have ourselves an interface for an author, and that's going to have an ID, which is going to be a string. We'll give them a full name, string, and what else? We're not going to do anything complicated like images or anything like that, so let's have it. That's enough. All right. So we'll make ourselves a couple of authors. We'll make a const called authors, which is an array of authors. Alright, there we go. Okay, so author 1, and we'll just use simple string IDs here, or like actually we'll just use some simple numbers here for now. Even though we'll obviously do more complex IDs down the track. I just want to keep it simple and not have to deal with UUIDs just yet. We're just testing out, we're just exercising our database. So I don't want to do anything complicated here just yet. We're already doing things that are complicated. Alright, there's my name. Alright, let's put another one. We'll put a Jane blogs. There we go. Let's show some biases. Alright, and then we'll have a Joe blogs. I'm not really feeling like being too original with our names today. Okay, so what do we need in addition to authors? Well, we need ourselves some articles. So with this, we're going to export an interface, which is going to be for article, and that is going to have an author ID. So this is going to be a normalized data set, which means instead of sort of storing the author in some sort of object, like say it looks like this, and then we actually put the object inside of it, we're not going to do that. What we're going to do is we're going to store the author ID, and that way we can go fetch it. And I mean, we'll eventually do something more complicated for that, but for right now, I don't want to do complicated, so we're going to avoid that. All right, so the author ID needs to be a string. There needs to be an article ID. And then, yeah, we'll use the ID as the slug sort of concept for now. And then we say we'll just have some text content, right? And that'll also be a string. Let's do a proper article. So it'll have a title and then content, and that will be your article. Okay. So if we export constant articles, or yeah, that'll do. We can just export default. That's right. All right. And what is the type of this? Expression expected. That's all right. Okay. So we do something like this. Entry 1, we'll make an author ID. So it will need to be either 0, 1, or 2. We'll just go for 0 for this one. And then we'll go title, entry 1, and then we'll go for content. And we'll just nab ourselves some lorem ipsum stuff. And we won't worry about anything like paragraph breaks or any of that palaver or anything like that. I'm just gonna make ourselves some lipsum, and the only thing that's gonna be different is going to be the titles for now. What did I do wrong here? There we go. Okay. So we'll have entry 2, oopsie daisy, entry 3. So for those of you astute viewers, you might be noticing that this is mapping the structure, or matching the structure of our routes, and that's because we're going to eventually feed in. We got to test something. We can't just test this in a vacuum or anything like that. Eventually we want to test it with our web app, and what better way to do that than to maybe load this article content while we're bringing in the page, right? So that's what we're going to do. So if we grab our articles there, we've got our concept of articles, and if we look at, let me jump back to our authors. Yeah, so rather than doing export consts, we'll do export default. Just chuck it in there. There we go. Okay. All right, so we want to grab authors. We'll call it all authors from testdata/authors. And we're also going to grab all articles. Done. Okay, so now that we've got the data, just some real quick and dirty data, now we want to figure out what our interface is going to be for when we want to sort of do stuff with this system, and what our interface is going to be for adding items to the author, adding items to the system. Now we could do something in bulk. We could do something in we could just do it one by one for pretty much all of them. And that's what I think we'll do. We'll just do it one by one for all of them. So let's do a little bit of a thought experiment. What we want to do is we want to get to the point where, say, when we initialize the route and the renderer, that should happen after we've initiated our data. So what we want to have happen is potentially something where, So the order for this is all wrong. So what I might do is I'll make a function for initiating the data. Initiate data. No arguments, and it's going to return a promise at the end of it that is going to say, all right, we're all good to go. So initiates. Let's do initialize. Okay, so we need to bring the migrations there as well. Very good. And at the end of this, what we want to expect is some sort of promise. So if we how do we think about this? Yes, so what we want to do is we've got all our authors, so we've got all authors and we've got all articles. And really what we want to do is return some sort of promise. And we're using the all construct here, which allows us to say work on like a collection of promises. And what will happen is that will only resolve when all of the promises that are made in there. So what you could do, so I've never done return promise all, so I want to make it clear for those who are not familiar with it. So if you were to create a promise with resolve true, so this collection of promises, what would happen is all of those would resolve, and you would end up with a promise at the end that then, once they're all done, you can then them. You can use this then argument to sort of do something afterwards, right? And if we have a look at our router, I believe this is where we've used a bunch of promises. Maybe not. Okay, well, we haven't used promises too much here, but we know for a fact that we've used our promises here. So we've got promises here, and you can see there they've got some sort of timeout, and then they either resolve or reject. Well, this allows us to sort of just contain that same logic and do it in a series of operations, and then once all those operations are done, it brings all of the results together, and then gives you something that gives you a promise that you can do with them. If any of them fail, then it will do the error function. So if we have the first one, which is a success, and that gets results, the second function will be the one that picks up if an error happens during that process. But what this means is we can say operate over all of the arrays, all of the authors, and then all of the operate over all of the authors and all of the articles, and once that's done, then we are able to do something, right? So one way to look at it is, say if we don't want to operate on the results here, we just want to let things know that it's done, right? So what we could do, so instead of providing all of the promises individually, what we're going to do is going to go all authors, and then we're going to map them. So for those of you who remember what a map does precisely, a map turns each item into something new, right? And what we're going to do is turn each of them into a promise. And we're going to assume that our little database system here should probably do that for us, right? So let's say we had some sort of insert command, right? Well, it'd probably be on a store basis. So maybe, let's maybe do it in a named fashion. So say we've got to insert an author. So that's to create a new author or something like that. So we're going to insert an author, and we're going to give it that A object, right? So we don't actually have that insert command or anything like that, but let's say this is sort of our ideal way, and this will develop over time, and eventually we'll figure something else better. But maybe create is better. I don't know. Insert item. there are so many things that we could use as our names here, or maybe save. Let's do save. We'll do save and update. We'll do that and we'll see how we feel about it. But either way, if that returns a promise, then that would potentially save us all our authors, or rather authors, because that's the name of the store here. Let's go with that. But what else do we need? So we've also got our concept of what's it called? Articles. So we need to save them too. So what we can do is we can concatenate them. So a concatenation is simply to put two things to put two arrays together. So if you had this and then you concatenated it with 5, 6, 7, 8, you would end up with an array that has 1, 2, 3, 4, 5, 6, 7, and 8. So that's just the simple result of a concatenation operation, and that's all we're going to do. We're going to bring them all together and then put them inside this promise all. So now we run on all articles and we map them as well. Return db.save articles, and again we'll feed them the A. So that's what we want to do, at least for now. And this will develop over time as we need to start to figure out, what it is that we're doing, what is the right way to build this system. But for the moment, let's assume that we don't know the best way to build this system, and we're just going to write some usage code, and that's going to guide us into how we build that system as we go. All right. So our goal for now is to get this to work, right? Because, it's all just going to explode for now. Now, we've got this initialize data function, and what we're going to do is we're going to initialize everything else after the data has been fetched. So if I get rid of this guy here, so even this state store concept, we're going to wait until after the data is fetched. So what we'll be looking to do is go initialize data, we'll get a promise back, and then assuming that is successful, we will then do everything else. And obviously this is a coarse way to handle startup, but again, we are in the early days and we will clean things up and make them nicer as we go. For now, that is what I'm happy with. Now, of course, it's going to crash. So if I refresh here, you're going to see a thing, DB is undefined. That's even funnier, because why is DB undefined? It's because these functions don't actually return anything, that's why. So now we need to actually jump into our implementation and figure out how we're going to meet the expectations that we've set in our usage code. So you can see here, nothing actually gets returned. No interface, nothing to work with, nada. Okay, so we need to deal with that issue. We also have more migrations than I really want, so I'm going to get rid of the other migration. That's sort of not my concern, version 2. Just going to comment that out, because we're not going to do anything to do with those other bits and pieces. We're just going to focus on authors and articles for today, because, there's a lot of work to get done. We may as well get it done. May as well focus on the things that we can work on. Now, luckily, I actually think this is a bit of a better setup by the looks of it than Chrome for looking after IndexedDB and that kind of thing. So let's see how things behave if I work with it here. DB is undefined. Now, nothing's there, but maybe I just need to hit this refresh button. Maybe that'll give me some data. All right, there we go. It's there. It's found it, but it's still crashing because DB is undefined. So we need to give it something to work with. We could sort of slack it and just sort of throw it something over the wall and see how it likes it. But oh yeah, we could do that. Okay, so let's return ourselves something with a save function. And that's going to be name, store, string, and object. We're not going to bother with type safety or anything like that just yet. But eventually we will go down that route and start to figure out what is a good way to handle this with proper types. But for the moment, let's just provide something like this. And you can see that that does actually get called. It doesn't return a promise, however, but because of the way it works, like if you don't return anything, those promises all come back as undefined, and it just goes, all right, everything's all good, right? So just to sort of put the promises in there and prove that there's some sort of delayed action happening, what we're going to do is we're going to return a new promise here, and we're going to put the resolve into a timeout. I'm going to go window.setTimeout, and that's going to be resolve, and that's going to be after 500 milliseconds. Actually, we'll make it a full second. So now what should happen is there's a delay. Yep, okay. So you can actually see that. So you can see that the render only picks up after a full second, okay? And that's not the delay of the router, but rather the delay of this data, okay? It doesn't actually get through all that, and then it has to carry on. So our concept of a promise here, it does work, but this isn't the whole story, right? So we need to determine whether the database is ready, because every time we delete this database using the storage object here, every time we delete that object, we need to make sure that we don't try to run any of these save operations until after anything that is required to start up the database is finished. And in order to do that, we're going to need some sort of promise concept, and we're going to wrap all of this for the moment into a promise. So we'll call it the database promise. We'll call it database ready, because the cool thing about promises is you can reuse them. Like, it's not like callbacks where you pretty much only get one shot to sort of attach them in the right place, or because then it becomes more of a listener pattern. But what you can do is you can have multiple things depend on this one promise, and when this one promise resolves, all of the things that have said they're going to do a new thing based on it, they will all go ahead and do that new thing, whatever it is. So it's a good construct for this sort of like multiple dependency. All of these things are waiting on this one thing to happen, and then once that happens, they can all go. They can all run free. Obviously, it's not good for scheduling. Like, if you really hammer the database, it's not going to be so great, but we can afford to be a little bit naive at the start of this thing, right? So we have this database ready promise, and what we're going to do is instead we're going to put this guy in here, and once we have applied our migrations, do note all of these should be synchronous, I believe, inside the apply migration system. So as long as we just wait until the end of this function, I think we are safe. Now, I might be proven wrong at some point, and if so, I will eat my words and then change my approach. But until then, we are good to go. So we're going to resolve with the DB at the end of that. And in fact, we don't need to. We can resolve with the DB at the end of onSuccess, because onSuccess always happens, right? So if we resolve DB, so we'll pull out the event target result here, because that is, we'll just put that as an any type for now, and we'll resolve with that DB at that point. If we get an error, we will reject, and we'll reject with the event itself. Okay, so this won't do a whole lot for us, but what it does allow us to do is in the API here, we can start to chain things. So what we can do, and I am well aware that this is not a great way to structure my code. I got all this stuff happening and all that kind of thing, but bear with me, we will eventually improve that, right? So what we want is we want to, based on the database ready, so we want to essentially do something where we go database ready, then something, okay? So with that database, we're going to do something. We don't know what that something is, but it would be great, trust me. And the cool thing about promises is you can also return promises within promises, and the thing that is depending on that promise, like it'll just eventually see through the layers. So that's another thing to be aware of. But the other thing is as well, is if you're just doing something synchronous, you can just do something like return true, and then that's all cool as well. Anyway, so we've made a very slight adjustment, and now we have something that works for everything, and then hits up to here, right? So what we should see, and we'll go to the console log for this, is so database ready, and we've got database upgrading. Yeah, we've got database upgrading, database ready. We've got a database error here, and we're going to just make sure that the flow of operation is correct, right? So here we're not actually saving, but we will eventually. So let's just make sure that these promises are flowing correctly, and what happens up the start is what is meant to happen at the start. So we'll start off by deleting WWA data. We've still got a connection open. Right, so potentially that's an issue. We are not removing connections, and at the moment we've preserved this DB, which means we've still got the connection. So we might have to do something a little cleverer there. Maybe if we don't preserve the DB connection, maybe that would be a way to do it. I mean, the alternative is we have some sort of function that allows us to close a connection after. So let's say we did something like this, where we close connection. Yeah, in order to do that, we would have to delete database ready. We'd have to clear it out of garbage collection. So already we're sort of getting a vibe that means we'll probably have to create some sort of data structure or object, maybe even, heaven forbid, a class to sort of keep all this together and sort of manage our database properly. So, you know, I'm not completely against holding classes or anything like that. So let's bite the bullet right now and build something that's sort of more precise. Yeah, so what do we want to do? We want to jump into client, platform, persistence, database storage, and DB. So this is sort of going to be our core DB API. Yeah, and we'll just call it DB. So export default class DB. Okay. So when that's the thing that we're going to return, okay, instead of this. And when we return that, what we're going to expect is that it's going to have itself a constructor. This is the thing that creates the object. And in that constructor, we're going to have to give it the promise of the database, okay? We can't just give it the database because I want to sort of make this construct sort of seamless to the outside world. So there's just going to be this promise always sitting underneath that sort of holds things around. But eventually it can go ahead and destroy that promise if it's decided, nah, don't want any more of that, right? So it's going to hold itself the DB promise. So it's going to be a private variable, the database promise. And that's going to be a promise. And if you remember our concept of generic types, that means that it's always going to have itself a handle of the IDB database. And in fact, we can change how this looks so that it's instead like this. And that way we can feed it that database promise. So what we're doing here is we're changing our setup. So instead of putting this function here, we're going to make it a method of our class here. So we just need to change a few things, and we don't even need this concept here anymore. We can just do that. So this database DB promise, and then we've got this concept of a new promise. So these complaints are only because I haven't saved the file yet. That'll go away once I've saved the file. Okay, so we want to grab that DB. So import DB from db.ts. And now instead of returning this object here, we're going to return a new DB, which has with it the database ready promise. Is that not a... And we have to make sure that it's always going to be resolved as that. Now, I reckon it does, but I don't think it's I don't think it picks up on what I'm precisely doing. So I'm just going to be really explicit that this is a promise of type IDB database, or like a generic promise that provides IDB database. And now it should be all good. Right. So when we do this, we've got, so when you put in a constructor like this, it automatically assigns this argument to code. So it automatically does this for you. It sets it up like this. If you say got rid of this private, then what you would need to do is also declare that private variable up here. So there's just a bit of shorthand. If you know that you're immediately going to put it on the object, you get to do it just like that. So now that we've got this promise, now we've potentially got a way to close connection. And the way we do that is, so with that function, we just simply delete this .db promise. And I believe that might get us home free, but I might just check the docs on this one. There might be an actual method that I need to call in order to do it. Go away. I want MDN. So the IDB database, what can we do with you? Fires the onClose event when it's closed during application shutdown. Returns immediately and closes the connection to a database in a separate thread. All right, so we can just run that. So how about we get rid of that and we go this.db promise. We do of course have to wait. So we can do db.close, and that'll do it. So I'm doing this literally just so I can actually delete this thing after. So after everything has been done, I will do a close. I won't do this in the future, but for the moment, I just want to make sure that my tools are actually able to do it. So do this. And then we go db.close connection. And that way my tools can get a handle on it. Okay, should I be able to delete it? Yes, I can delete it, which is good. That's what I'm after. So let's just check that execution order, because that's what we actually decided to do all of this for. So here we go upgrade needed, and it goes through add store, adds index, all good. And then we get a database ready event. And then it goes through and saves the authors, although it doesn't actually go through and save the authors. That's just our console log at the moment. And then down here somewhere it closes it. We don't have a console log, but that's all good. We might as well chuck one in. Okay, and you can see that slight delay there where it's taking some time, which is good because that's based on all those timeouts there. All right, and you can see here we got a database ready event this time because it didn't have to do any upgrades. All good. All right, so now let's talk about saving items. So we need to put some data into the store. And in order to do that, I believe we need to get a hold of the object store. We need to create a transaction to do all of the work. So it starts with our database object. And if I lead us a slight bit astray, I do apologize, but we're just I'm trying to pick up some of this this knowledge as I go. Like I did build that library oh so long ago. The tools were a lot worse back then, and I had to support Web SQL. So there are a lot of different focuses that I had to do when I put that thing together. But now the focuses are different. Right. So what we will need to do is we need to create a transaction that works with the particular store that we're working with. You can also you can access more than one store at a time if you like. But for the moment, what we're going to do is focus on operations with singular stores, and we'll worry about making things more efficient as things go on. So we need those store names, and we also need to provide a mode. And that's in the form of this read-write flag. And we'll just make that as a constant up here. So we're going to keep it simple, and we're going to start ourselves with a promise right here. And we know that we have a few things that we need to do. So we create ourselves a transaction. DB, TX, and then we'll call the variable TX, and we'll run a transaction on it. And that will use the name of store. And because this is saving, we know that we need to be able to read write, or just write technically, but read write's fine. Okay. Now once we've done that, we need to do stuff with this transaction. So oh, it looks like we can just grab it. Yeah. So we give it its instructions. We grab the object store, and then we're able to work with that object store. So we can grab our store by going tx.objectStore. I made a mistake there. Object store, and we again want to grab that particular store. Probably noticing that this is a little right, yeah, I'm overriding the, let's go with that instead. And that way we can use store name here, and also store name here. Right. Now that we've got that store, we should be able to add. All right, that's interesting. So we can just add things, and that's it. But let's check out the API for it, and then we'll make sure we're not making a horrible mistake as we do it. So we've got add, we've got delete, we've got get, and have we got update, put. So here we've got the way to perform updates. And eventually we'll probably do some smart so that we can do either add or put. But for the moment, we'll just use IndexedDB add. All right, so we've got the value and the key to use to identify the record. I do wonder whether we need to use the key. I think if we've already got a key path, it might be unnecessary. So we can just probably have a crack at doing it without that, and then we'll go from there. And then it creates an object store request on success. Okay. Yep. So we need to jump in here and put ourselves a const store request. Actually, sorry. I need to mute for just one moment. I'll be right back, and then we'll go through this. I want to sort of be able to focus on it entirely, so I'm just going to be 2 minutes, and then I'll be right back. Alrighty, let's get back into it. So this store request. So we're going to take the store and we're going to add an object to it. And that object is going to be of the shape of obj. And that would be part of the story, but we also need to do something on success. We need to resolve this promise, right? So we could do a store request dot on success. And we'll get from that a function. It's going to be an event. Not that I care too much. And all I'm going to do is I'm going to resolve the event. We would eventually do something a little more intelligent than this, but for the moment we will just resolve the event. If the store request fails, so on error, and we will reject that event. We've got two events there, all good. What I believe is that transactions automatically close themselves, but I just want to check that one out. So I'm just going to take a moment to read this and have a look around. So transactions are started when the transaction is created, not when the first request is placed. So the transaction starts here up at TX. And then we do a bit of work. It never actually says when the transactions finish. Yeah, so this is the thing. It never actually talks about how these transactions complete. And I believe it's pretty simple. My sort of layman's understanding of it is that when you create a transaction, in this synchronous piece of code, you need to make sure that you've made every request that you need to. You've held it open. I do recall having some issues with transactions where I've had to do something a bit more complicated. And like I did that in my my library. But for the moment, let's just roll with this, that the transaction will end, and then we can resolve on that. So what we might do is, instead of doing it on the store request, we're going to resolve on the transaction end. So on complete, just to check my assumptions here, because God knows they can be wrong. So we're going to resolve on the transactions complete function, and we're going to reject on the on error. And we're not running any aborts, so we don't need to catch for that, but we will eventually handle things like that down the track. Well, potentially this is our first bit of code going in, so let's have a crack, have a look, see what happens. She didn't work? Nothing happened? Ah, I've got nothing to detect whether that actually happens. So let's check our storage and actually see what went into them. So we can actually see our data in there now, which is good news. So we can see entry 4, entry 1, entry 3, entry 2, and we've got authors just here. Okay. Well, if this is the case, let's not close the connection anymore. Let's see if we can make use of the connection to maybe get some information. So I want to get rid of that. And I want to, after all of this is said and done, I want to return the DB. So the database is what comes out of initialized data, or rather a promise of the database. And we can see that right here. Now we need to provide that that database somewhere, somehow. So I need to think of a decent way to pass that in. And I don't really have a decent answer for that just yet. But what I want to do, what I'm thinking of doing, is sort of pushing that through to the router for now, just so that we can make use of it inside these little pre-render functions, because we'll need some things on hand, and maybe we will sort of we will have ourselves some sort of app context, right? So yeah, we'll export an interface called weekends or web app context, and that'll just be for the things that are generally needed to do stuff around the application. And one of them is having a database on hand, or a DB object. So I'm going to call it DB. It's going to look like that, and we're going to just grab the type from our platform layer. So we'll import DB from platform / persistence / database / DB. And then we will make use of that for the routing rather. So we need some concept of that. Now this is a bit rough because obviously I probably should be pushing something into this context. Actually, no, I can do this with generic types. So let's do just that. So C is context, and we're going to have ourselves C just there. And what's going to happen to that context is that's going to get passed into every one of these render functions, or preload functions rather. So here where we've got this preload, we also want to give it the context so that it can do something with it. So the preload function, instead of being two different things, it's also going to accept some sort of context. And that's also optional, but it's actually, we've pretty much made it so that these are non-optional anymore. So let's just get rid of the illusion that we can keep these separate. Or we can just do that. That would work too. All right. So now we're looking at our generics here as well, because we need to suddenly now we need them for all of these different places. So maybe I've just opened a rabbit hole and I don't really want to just yet. So instead of doing that, what we're going to do is make them any types just for now, and we'll clean up our type system down the track, because just keep in mind we are in exploration phase here. Eventually I will look at this and we'll sort of have to make a decision as to what's the best way to push the context along. Okay, but for the moment this is the best idea I can come up with, or it's not the best idea I can come up with, but this is the amount of thought I actually want to put into things just right now. So we're going to create ourselves a context. And at the moment, all it's going to do is have a type of DB, which is from that DB up here, at the end of this promise here. Let me just pull in weekends web app context. All right, jump down here and yeah, so just remember this is that shorthand for that. Because they're the same name, I can just provide the value. And we're going to chuck the context in here. And that's going to ideally give us access to the context inside any of these places. So let's just check that. We'll go to some of the entries. And we'll make it weekends web app context. And we'll go console log .context and see if we've actually got access to it. And so what the usage of the word context, the idea of the word context is that it's providing us a way to talk about what it is that we have available when we do this particular thing. Now, database is ready, but it's never actually getting through. Why is that? I have maybe made a mistake, so let me see if I can rectify that mistake. it's just stopping. Is that potentially because I've got all this stuff available and something's crashing in the middle of it? What I might do is delete the offending new items and see if by deleting that, oh no, I can't delete it because all the connections aren't closed. Alright, well, it seems to be working now. So, oh no, it did actually do the delete. So I think there is something going on there that's giving us problems if we don't delete the database before before reloading. And it's possibly because we're using save and it's violating some not unique sort of thing. Notice that we didn't actually get an error on the transactions. So what we might have to do is just jump into our DB file. Oh, are we already there? We'll be there now. Okay, and we will just have to do something here where we, at the very least, get some information about whether something went wrong. We'll just console log ev, save error. Alright, so that is exactly what we get. We got ourselves a save error. And here we go. A mutation operation in the transaction failed because the constraint was not satisfied. So yeah, if something already exists with, say, a unique trait or something like that, then it will violate that. But yeah, a very key thing is that doesn't necessarily bubble up the rest of the way, that failure, which is a problem. Let me just double check that that is the case, because I just want to see if there is in fact a TX error happening as well. Alright, so that TX error, that never finds it up anywhere where I'm able to then act upon it. But yes, it is important to know that we have this save error. There are ways that we could potentially deal with it, but we're not going to right now. We're just going to keep on destroying this database and then reloading, because everything works at that point. Okay, so we've got, this is an entry page, entry 1, and you'll see here we've got this DB object here. And that's, yeah, got the DB promise, and it's got save and close connection. So we need to have something that's going to allow us to now try and get this thing. And this will probably bring us to the end of the stream because there's only 5 minutes left. I know it's slow going, but eventually once we start to get some basic constructs in here, we'll start to be able to spread out to all of the things that we want this to do. So we want some way to get something from a store. So we'll go get by key. So essentially get by the main thing that is keying it. So we'll have a store name, and then we'll have a key. And we'll just go with string for now. I mean, eventually we might need to support other things than strings. And we definitely need ourselves this sort of setup. We should be able to do a transaction without any sort of read-write flag. So we can go ahead and do that. And then let's take a look at the API for object store. So we still need to get that. We do the transaction, and then we get ourselves an object store. So all of that code is pretty much identical. The only thing that changes is the store request. So where is that store request? What do we got here? We got a get function. What does that look like? So the key or key range that identifies the record to be retrieved. So this would be based on whatever's in the key path. So I would assume that if we were to just chuck it key, oopsie daisy, and use get, we should be able to get the thing out of this, get the thing that we want out of this. And here we can see that it's inside the object store request on success part that we actually get what we want. So we can't just use the transaction as a means to detect success here. We need to use the on success here, and we need to resolve against that because we want to get what we want to get what we're meant to get out of that, right? So let's resolve, and that is, if I look at this, so we've got the result from object store request. So store request dot result, and that should be the object or the thing that we're expecting, right? And what if it fails? Well, this is where it gets interesting, right? Well, see, at the moment we depend on the thing that comes back being something that we can find, right? So you can see that right here. You can see that right here. We've got these new data forbidden or new data not found. Well, how about we start to grab some of those various errors, and we will find a better place to put them eventually. But for now, let's just go and grab them from where I believe they are, which is in routing. I believe, yeah, well, it hasn't blown up, so I'm assuming we've got ourselves a good state here. So if we do this, and we go data not found, so we're going to reject with a new data not found error. Now there are a lot of other errors that could happen in this case, but we're just going to start with the assumption that data not found is, oh, I did data forbidden up there. Yeah, we're gonna start from the ground base assumption that data not found is acceptable. So and we're gonna use the key for it. So key article could not be found. And we could probably, yeah, we'll get rid of the onComplete, and so the TX errors, we will just sort of disregard them. They shouldn't be necessary anymore. And we'll just use these store request sort of bits and pieces. So what we're going to do is change this out. So instead of doing that, we're going to return ourselves something that uses context.db.get by key. And it's going to be from articles, and it's going to use params.slug to get it done. So unless I've made a horrible mistake, this should actually work. I will just go through and delete the storage just to start off with. Maybe I've already done that. Maybe I have. All right, let's do a reload. Okay, that one crashed because it didn't delete from last time. Okay, let's do a reload. All right, now we are good to go. Okay, so this is entry 1, that worked. Let's go home, entry 2. Okay, these are all happening immediately because the database is pretty quick. It's pretty small, right? So what we're going to do now is we're going to check and see, this is going to complain just because the database keeps on having to add these new items. So what we're going to do is very quickly comment out our usage code where we add all of these items. So instead of all of that, we're just going to return an empty array, which I believe should just be successful. Right. So that's just getting rid of all of those additions so that we're not constantly churning the schema. So now we've got the database ready, and entry 3 worked fine. Okay, that's good. Let's see entry 4. Now entry 4 should now work because we have permission. It's in the storage, if I remember correctly. So we'll have a look in here, and we'll look in articles, and we can see entry 4. So the moment we go up one though, entry 5, okay, so that one succeeded. So we need to find out why that is, because it shouldn't have succeeded. It should have failed. And I'm noting the time. We're going to sort out this this one bug, figure out what exactly is going on that's making this not work as we intend it to, and then go from there. So somewhere in here, something that shouldn't be happening is happening. So if we go, we'll console log on both error and not error. And we'll start here as well. make sure we're actually calling the function that we're expecting to be calling. And let's have a crack. All right, get by key articles entry 5, and we have a success. Why do we have a success? It doesn't feel right. Maybe it doesn't actually provide one of these if it doesn't find anything. So store request result. Oh, okay. So it seems to return an undefined. So it's still successful even when there's nothing there. So that's a problem. So instead we need to escalate this this reject up to here. So it's if store request dot result does not equal undefined. So anything that equals undefined is bad news bears. If it is not undefined, then we should have ourselves a viable object. So I'm just going to improve this a bit because I shouldn't use the word article in there. And we'll just chuck this down here, although this will probably be indicative of some other severity problem. So we'll still reject it. We just might not make it a data not found error. It might be something like, let me check routing. I have a server error in there, don't I? All right, actually, no, I can keep that data not found error and just do a normal reject down here, something that's a bit more severe. So we'll just make a new error. Database had an error, had a boo-boo. Doesn't know what that boo-boo is yet, but we'll figure it out. Okay, so now that we've done this, so we've got to resolve if it's not undefined, otherwise we reject. Now that we've done that, you can see here, we've got a 404 error. So entry 5 in articles could not be found. And we'll have that same pity party if we go to entry 4. Actually, we won't have that same pity party if we go to entry 4. So it found entry 4, you can see that there. We can go home, we can grab entry 1, entry 2, and entry 3, and it's nice and quick, all of them successes. So that's sort of, it's the beginning. We've got some data access. Not particularly great data access, because we're not doing anything after we get it. We're not putting it into the in-memory store so that we can actually use it for rendering or anything like that. But we have a start. So that is, I'm going to call it there. We've added some data and we've got that data out of the database. We still need to do the transition where we take that data and put it into in-memory. So remember, the database is sort of a form of persistence, but we haven't actually done anything with that item once we've got it. We haven't actually put it anywhere that's useful. So we need to go ahead and do that the next time we pick this up, which will be on Friday, 8 p.m. Australian Eastern Standard Time. If you have any questions, please fire them up. I will be just going through and committing all this work, and then we will go from there. I'm going to get rid of all of this because we no longer need it. I don't want it. And now, yeah, we'll make ourselves a commit. And then we'll pick it up on Friday. All done. All right. So we are on day 11, I believe. So continue IndexedDB, add ability to save and retrieve records. We can't update records though, and it doesn't like it very much if we try to do it right now. It ends up crashing the database and horrible things happen. And we will eventually handle that properly, but for now we will just work around it. Okie dokie. That all done. I'm going to tag with day 11 and push the lot, including tags. All right, that's all up. So as per usual, I'm just gonna visit it every once in a while just to remind people it's there. The code for all of this is available at github.com/weareoffsider/weekendswebapp. You're more than welcome to poke along with it, check it out, try things out with it, try new things. Has it not picked up that? I'll do the push and then I'll go, yeah, I didn't like it. Updates were rejected because the tag already exists in the remote. If I do that and then do that, I got to delete my local tag of day 3, and then it will stop complaining about that one. But anyway, that code's up. And yeah, so you've got, you're welcome to clone down the code and carry on at home. Do whatever you want with it. Especially all the platform code, once it's sort of nice and set up, the idea of this platform code is intended to be something that you could use pretty much on any app concept that you want. Obviously, it's very opinionated because it's code written my way, but that is the intent of it, to be something that can be reused in all sorts of different places. That's pretty much it for me. I haven't seen any questions or anything like that, so I'm going to call it there. I'll be back on Friday night at 8 PM Australian Eastern Standard Time. Till then, see you around.